it's some sort of integral of this.
It's the integral of the length of it.
Yes, and just want to pull that up here. And then, we can, do you have to do these by hand or are you allowed to use calculators?
Well, this is a homework, so I'll use a calculator, but
Okay, so the length is the integral from -5 to 5 square root of, and then you have to take the derivative of each one of these and then
right.
square it. So it's derivative of sine is cosine, so we got -7 cosine t squared plus 3 squared, and then derivative of cosine. Well, it doesn't really matter because you're squaring it, but it'll end up being 7 cosine t. I'm sorry, sine t. With the sign change, and then you square that dt. Now,
Right.
is there a way to do this by hand? I have no idea. Because it's web work, you probably know this by now. You can just get a calculator that does this, and then just copy in the numerical value. And so the one, I mean, there's so many out there. I mean, I like Wolfram Alpha for this kind of stuff.
Okay.
But let me are you familiar with some of those calculators?
I think I used to have one, but it's broken.
Okay,
So
I'm
I
talking
haven't had it
about
recently.
I'm talking about on the web. I'm talking about you just go out to somewhere like a integral calculator.
Oh, okay.
And I mean, I can show this to you if you would like, but it's you just type in the bounds, and then you gotta, you do all this stuff. So it's 49 cosine squared.
Do you know how to do it by hand?
This one may not be possible by hand,
Okay.
is the point. It depends. Some of these get really wonky pretty quick.
Right.
Actually,
I tried to solve this one earlier, and I
take this back. You can do this one by hand because it's 49 cosine squared t plus 49 sine squared t. Okay. And
factor out of 49.
you factor out of 49, and then this part becomes 1 because cosine squared plus sine squared plus the 9. So it's actually not that bad. We didn't need to go to calculus. So it's the square root of 58 dt evaluated. So you're doing the integral of this -5 to 5. And then so it's the answer is the square root of 58, 5 minus -5. So it's 10 square root 58.
Why would you do the 5?
Because it's really 5t or square root of 58t. Like this is just a constant.
Right.
So it's the integral of dt, which is t, and then you evaluate the upper and the lower bounds.
So you just do the upper minus the lower?
Yes. And I shouldn't skip some of those steps, but the more we move through this courses, I just, less you need in general. Yeah. So you're this is
the wrong answer.
It didn't like that.
Oh wait, never mind. Just kidding. I did a wrong problem.
Okay.
Okay. All right, that's correct.
All right.
So most of the honestly, I think for all these formulas we've done, it comes out like that, where we can factor out a number and just get cosine squared plus sine squared.
I hope so. That's not usually the case. I mean, and sometimes they just say set up rather than.
Every time we've done one, she's done it like that. So
good.
I think it'll be like that.
So in your next problem here, r of t is 5t t cubed over 3.
And is it just the same thing for this problem? Just
yes,
same formula.
Yeah, you got to take a derivative. This one becomes t squared.
Yeah, I got to remember my derivative laws.
Yes, cannot forget those. And so.
And did you get square root of 10 t because you moved the 2 in front of the square root of 10 and it cancels out? Okay.
Yes. So then you square each of these.
Right.
And this one, so it's integral -2 to 3 square root of this stuff. and it ends up being a perfect square trinomial. Shocking that it actually worked out that nicely. So this becomes t squared plus 5 squared. And that's a perfect square trinomial. We can
How do you, is it?
So it's a squared plus 2ab plus b squared, and that always resolves to a plus b squared.
Okay.
And in this case, your a is t squared because it's to the power of 4.
Okay.
So the integral becomes -2 to 3. The square root cancels that, so you just get t squared plus 5 dt. And now it's just a basic Calc 1 integral.
All right.
1/3 t cubed plus 5t evaluated from -2 to 3. And again, WebAssign will, I'm sorry, WebWork will allow you to just, you can just put in this awful expression. You don't have to actually calculate it.
Oh, okay.
If they didn't show you that, but you gotta be really careful with your parentheses. If you've got unlimited attempts, I would suggest never simplifying these ever. Yeah, to just run out of.
And whatever number you get, it's the
yeah. I mean, so this class is less. I mean, for me and you, it's probably less about these final calculations. It's more about setting them up and
all right.
and doing them. But if you need me to, we can go through them. So I see you sent over another problem here on arc length.
Yeah, it's
Right.
arc length and curvature homework.
Right. So the vector r is 1 I hat plus 3t squared j hat t cubed k hat, and we're going from 0 to the square root of 12. So you take a derivative, 0, 6t, and 3t squared. Okay, and then you square each of them. So we got 0 squared plus, this becomes 36t squared plus 9t to the 4th. And that's what you're taking the square root of, 0 to square root of 12 dt. So this one requires a little more effort here. You can factor a 9t square out of both. And so that leaves you with 4 plus 9, sorry, 4 plus t squared, square root of that. And then you can square root each of these. So this becomes 3t square root 4 plus t squared. And that's still all inside the integral dt.
Could you not take the square root of 4 plus t squared?
You cannot. There's nothing to do on that one.
Okay.
It's you treat it like it's in parentheses. So you need it to the power of 2 to be able to do something.
Oh, okay.
All right. Now the this is a u substitution problem. You let u equal 4 plus t squared. And your u prime is 2t dt, or I guess let's do it this way. du equals 2t dt. We can change the bounds if we want, but it's 3t square root of u, and then dt is du over 2t. This is just a regular old u substitution.
Right.
So it becomes 3/2 square root of u du. And then we can integrate this. It's really u to the 1/2 power. Let me write that. That will help here. So when you add 1, you get u to the 3/2, but then you divide by the new exponent, so those cancel.
Where'd you get 3/2?
Because you're adding 1 from the integral. The integral of u to the 1/2 is u to the 1/2 plus 1.
Okay. Where does the 3t go?
It cancels out with the 2t. The t's cancel.
Oh, and then the 3 is just sitting there.
Yeah, 3 over 2.
Okay.
All right, so so we've got the antiderivative now. It's u to the 3/2. But u is t squared, 4 plus t squared. So it's 4 plus t squared to the 3/2 power evaluated from 0 to square root of 12. So that's 4 plus, and the t squared undoes the squared. So it's 4 plus 12 to the 3/2 power minus 4 plus 0 to the 3/2 power. And you should be able to just enter it that way.
All right.
Any questions on that?
Nope.
All right. So I don't really understand the next question. Web work questions are readily available online. So I'm going to look up and see what it's actually asking for.
Okay.
It's talking about re-parameterizing the curve. Okay, let me so the point here is 3 comma minus 1 comma minus 1, and they give you r of t equals 3 plus 3t I. You can see all this minus 1 plus 3tj. And I forgot about this. So you're supposed to figure out the value of t that gets you this point. So you try values of t like 0 and 1. Okay, now you can actually solve for it directly. You can go 3 plus 3t equals 3. I'm getting that from this coordinate right here. Minus 1 plus 3t equals minus 1, and so on. But generally it's like it's kind of obvious when you try a number and you get it and you're like, okay, we got it.
Right.
All right, so that's the first thing. All right, so when t is 0, which is what this ends up being, your r of t becomes the following. Your r of t, I'm sorry, no. That comes in later. So we first find r prime of t. Okay, so we're taking the derivative of each of these coordinates. It's 3i plus this one is, that's not right. Sorry, I'm just looking at this thing. The solution isn't right. Okay, yeah. So 3j and 3k. There's our derivative. And then you take the magnitude of that derivative. So you're doing an arc length calculation off this, I guess, in short. So you take the derivative and then you square it. So it's 9 plus 9 plus 9. Square root of that integral is from 0 to t. But that's a problem because t is 0.
Right.
Why? So they're doing something else here. Why are they doing that?
It says that t equals 5. Oh wait, never mind. Look at the wrong one again.
Yeah, sorry. I know I'm not snipping them in. It takes a little bit longer to do that, but the when t is 0. So I've been full scale. I don't fully understand this at the moment, but this is the square root of 27, and then you're integrating it from 0 to t, and they do this thing here where they say s is equal to this integral, and you flip it. So this is square root of 27t, and then your t is really square root of, I'm sorry, is s over the square root of 27, this thing I'm looking at. And then this is what goes in for t in that first part. So does it say to answer in terms of arc length s? Yeah, it does. So see how it says t of s? Yeah, it's very wonky. So your answer is 3 plus 3s over square root of 27. That's in the first box, I. And then minus 1 plus 3s over square root of 27, j. And then minus 1 plus 3s over square root of 27, k.
Okay. That looks familiar, kind of.
It's an odd parameterization in, full disclosure. It's a little, it's really weird. You see it more in linear algebra, this type of re-parameterizing, but I guess they found a way to sneak it in here.
All right, I'm shooting you to the problem. I remember this re-parameterizing. I just don't know why you do it.
Yeah, but you're gonna later on, you're gonna be doing some integrals where you need to of this. So the parametric form of the tangent line to the image of, okay. So I'm guessing we've got to take another derivative of this, but let me check here. 3t squared 4 over t minus 5.
Everything good?
Yeah, I'm finding a reference here
Okay.
for us. Let Chegg be your friend, that kind of thing.
Yeah.
So you take the derivative of this, and so f prime of t is 6t minus 4 over t squared comma 1, and then you evaluate. You put your t value in to this. Let me get back to your question. There it is. So your t value of 5. So you do this f prime of 5. 6 times 5 is 30 minus 4 over 5 squared, comma like that. And then, all right, let me go down here. So that gives us 30 comma minus 4 over 25 comma 1. Right. And so there's a formula here that I see. That's why this is so important. There's a formula. So the parametric form L of t is f of 5, okay, plus t times f prime of 5. That's your normal tangent line. So we have to put 5 back into the original. This original thing here. We have to put 5 in.
Okay.
That's what f of 5 means. Original, and then we have it at the derivative, and then we add them together here, or you're going to see this shortly. So let's go back to the original and put 5 in. So when you put 5 in, f of 5, I'll do that in this. I got a little room here. So that's 3 times 5 squared. That's 75 comma 4/5 comma 0. And this is where I think it's going to get a little. No, I guess we can still do it. So we take that vector 75 comma 4/5 comma 0. That's the f of 5. Plus, sorry for scrolling around, plus t times this other vector 30 minus 4/25 comma 1. So your final answer for L, the x component is 75 plus 30t. So you take the x there and the x there, but you're multiplying it in, comma 4/5 minus 4 over 25t, comma, you'd have the 0 here plus just t.
And that's the answer.
That's the answer. You got to enter that as a vector, which
Oh, all right.
I guess it's already. So you somehow have to enter that in vector notation, which I don't remember. Maybe you just do angle brackets. I haven't done.
Yeah,
I haven't,
these usually greater than.
yeah.
Okay, I'll see the next one. Can you scroll up a little bit?
Yes. Sorry about that. Okay. So we've got r of t, which is t squared, comma 1 minus t, comma 4t. And our goal is to find a product rule derivative of r of t times a of t. So we're going to actually use the product rule for that. But we will need some numbers. So we need r of 9. Yes. So that's 81, comma, just putting 9 in for t, minus 8 and 36. Okay. And so our product rule derivative is r of t times a prime of t plus r prime of t, a of t. So we need the derivative now of r, 2t minus 1 and 4, and then we need the derivative at 9. So 18 minus 1 and 4. So then like this notation here is a dot product.
Right.
I believe that's what we got here. Let me just look one more time. Silly phone isn't working, cooperating. So you're going to take r of t, 81, comma minus 8, comma 36, and you're going to dot that with a prime, which is 9, 3, and 7. And then you're going to add to it the dot product of this derivative, regular 18, minus 1, comma 4, dotted with a of t, which is given as minus 8, comma 6, comma 7. So if you don't want to do this, you just have to show the work. So it's 81 times 9, or you can use star, plus negative 8 times 3, plus 36 times 7, plus 18 times minus 8, plus negative 1 times 6, plus 4 times 7. But the key part is that product rule derivative, that you remember that from
Okay.
previous class. And hopefully I didn't make any numerical mistakes. I'm checking it over now again.
Nope, you got it right.
Maybe more importantly, do you feel like you could replicate that on a future
So
assessment?
let me relook at the problem. Okay. It's just product roll between both of them.
Yes, and it's just,
Okay.
it's magnified because it's I, J, and K, X, Y, and Z rather than just being an X. It's like 12 problems instead of, instead of one.
Okay. Okay. I get it. It makes sense, but weird. All right. I got the next homework problems I had questions on. It's about velocity and acceleration.
Okay, so some more derivative stuff.
Pretty much. I just don't know with the initial velocity thing and the initial position vector thing. They're just kind of, I don't know what to do with those, or if even if I'm supposed to do anything with them.
Yeah, let me, it's just came in here, so let me grab it here. Yeah, okay. So they're giving you, yeah, so this is important. So they're giving you the acceleration vector -4 cosine -2t. And it's really like 3 separate problems. So I'm gonna show it that way. And 3t. So let's do the easy one. What is the antiderivative of 3t?
It's been a while. It's
You add
3
1 to
halves t squared.
3 halves t squared, yeah. But it's plus c, okay?
Right.
And that's where that v of 0 comes in. See how the third,
Oh, okay.
so
Okay. We did something like this in class.
because
Okay.
it's a polynomial, you can just assign it to be that value of 1
So
and that
that'd be
third.
+1.
Yes.
Okay.
Now where it gets more, I mean, it's just calculus, and it's a lot of back and forth.
Yeah.
Derivative, integral. So the antiderivative of sine is cosine, but it's minus cosine. That's where you got to be like really strong with this stuff. And then you got this stuff
On the
inside
chain
here.
rule.
Yeah. So this is where it's like, this is not really part of this course, but you need to be really good at it.
Yeah.
So derivative cosine is minus, this is actually negative, plus c.
And how'd you get a 2 there instead of the 4?
So it's more of a guess and check approach where I just take the derivative of this. Derivative cosine is minus sine, so that would
Right.
make this positive 2. The derivative of the inside is -2. -2 times 2 gets me to the -4.
Or are we supposed to be taking the integral?
Yes, but
Oh.
because sine and cosine go back and forth, and it's easy. I'm just sort of guessing until I get it right.
Okay.
Like the pure way to do it is to be like make a u substitution, which you don't have time for now.
All right.
You're supposed to say, oh, it's -4. The antiderivative of sine is minus cosine. And then I divide by -2.
All right.
And so I'm trying to like do all that without,
Yeah.
yeah. So then you put 0, you put 0 in
0 right
for
there.
t. Cosine of 0 is 1. So this is -2. I'm sorry. Yeah, you put so
Or I thought the 0 went where the c is.
no, it goes in for t. So it's -2 cosine -2 times 0 plus c. And cosine of 0 is 1. So this becomes 0 equals -2 plus c. It only goes in for c when it's a polynomial and it's at 0. So
Oh,
c equals
okay.
2. So your v is -2 cosine -2t plus 2. And most webworks you can try out. Like you can test as you go, and I would encourage you to do that. Like we should try that, this one is right, and then this middle one is right. And then we're going to similarly do it from here. So this is like 2 sine -2t plus c for your antiderivative.
Okay.
And then you're yeah, like you said, you're putting 0 in for t. but now it
Or-
equals 1 because that 1, 0, 1, that velocity.
Uh-huh.
If you need me to step in the questions, I just need a little more time to be able to upload them and grab them. But it's 2 times the sine of 0, which
So
is 0.
you only put in the numbers as C when it's a polynomial?
Yes.
Okay, I don't remember her saying that, but I probably missed it. But other than that, you make the T0 and equal it to the number.
Because they're giving you V of 0. If they gave you V of 1, which I might do if I were teaching your class, you'd put 1 in for T, or something else. So 1 equals 0 plus C, so C is 1. And so we're down to 2 sine minus 2t plus 1. This is your V of t line.
Okay.
And if you can, please check that because all the answers are going to be dependent on this.
Okay, I'll check right now. Okay, that was correct.
Okay. So R of t, we're going to take yet another antiderivative. Let's start on the right side because that's the easiest.
Right.
It becomes 1/2 t cubed plus t plus c. And then they tell you that R of 0 in the third position is 1. I mean, they're all 1, but that's the K, the K component. So it's 1 equals 1/2 0 cubed plus 0 plus C, so C equals 1. So your final answer is that 1/2 t cubed plus t plus 1.
So why didn't you put the 1 in for C?
I'm just showing it to you. When it's a polynomial, it is just the constant.
Oh, okay.
Yeah.
Oh, I see what you did. Okay.
Okay, but for the other ones, it won't be. So we'll
Right.
move to the middle here. Antiderivative cosine is sine. So sine minus 2t. Derivative of sine is cosine, so that part checks out. Minus 2 times t, the derivative of this is minus 2. That works with that. Plus 2t plus c. So that's the speed your teacher's expecting.
Yeah.
Which, so it's a lot. So again, you have this R of 0 equals 1. So 1 equals sine 0 plus 2 times 0 plus C. So it does end up working out that C is 1,
Okay.
but kind of dangerous to just generalize that
Right.
to everything. And then over here, we've got cosine minus 2t, but there's a negative because root of cosine is minus sine. Wait, yes. Wait, no, wait a second here. Cosine gets you the minus sign, but then we multiply by that. Okay, plus t plus c. And then we have that R of 0 equals 1 again. So 1 equals cosine 0 plus c. So cosine of 0 is 1. So that means this time that c is equal to 0. So it's just cosine minus 2t plus t.
Okay.
I mean, a year ago, you wouldn't have known what a derivative is, integrals, and now they're just, it's all together. You got to be willing to, if you want to do well, you got to really kind of get on this.
So for this question, I just don't know what it's talking about, to be quite honest.
So we're past problem 2. Got
Yes.
another one. Okay.
It's sending right now.
All right. All right, this is actually very straightforward compared to the other ones. And you've done part A correct. Have you already checked that?
Yes.
Okay. Use x prime of t and y prime of t when x of t, y of t are increasing and decreasing in terms of t values. Huh. Oh, that's horrible.
I just don't know. I just don't even recognize this.
Yeah, I don't either. All right, let me check here.
Look on Chegg.
All right, so you have a good starting point here. So x prime of t is 2t, and if we were to set it equal to 0, we would find that at t equals 0 is our critical point, and it's increasing over here and decreasing over here.
Right.
Okay, and so we do the same thing for y prime of t, and we're gonna see where they overlap on there. So y prime of t is 3t squared minus 5, set that equal to 0. There's actually 2 critical points this time. You have the square root of 5/3 negative, square root of 5/3 positive. Since it's a parabola, you mean you can do your sign charting stuff, but parabolas go down and then up. Okay, so up and to the right probably means that the derivative, but they're both positive, which doesn't look like is anywhere. Let me see. Up and to the right. So if we were to overlap the two, like that's what I'm trying to do here. Let me grab a thing here. So there's now 1 region, 2 regions, 3 regions, 4 regions, and we just need to sort of. So x, okay, that's good. So they actually kind of like the way this picture is on online. They show it this way. So let me just put those points in again. So minus square root of 5/3, 0, 5/3 square root. So they do x. So when x is positive, and we know x is positive when it's greater than 0, they go a little arrow to the right. And otherwise it's going to the left.
Right.
But why do they do that? This one's reversed. This is weird. Oh, because it's negative 8t. Okay. We got the right derivatives, right? It's 2t. It's not negative.
Yes.
Okay. And so these are going left, and then what do we want here? Up and to the right. Okay, so y is positive here, and down, down, and then back up. Okay, so y and x. So that the y means going up is when it's positive, and x is going to the right when it's positive. And so now we're just meshing these into this. So up and to the right is this interval on the right here. And that's from square root of 5/3 to infinity. Up and to the left is over here on this one. We're just following the arrows. And that's from minus infinity to minus square root of 5/3. And then down and to the right is this one right here, down and to the right. So that's from 0 to square root of 5/3. And then down and to the left, that last box, minus 5/3, comma 0.
Okay. I'm just trying to look at it and understand it.
Meshing these two sign charts together.
Okay.
It's there's a
So
lot.
how did you get square root of 5/3?
So that was solving this equation for 0 for
Okay.
y, and that gets you the two critical points.
And what was the point of doing x at the x prime equal to 0?
You got to know, so the x prime tells you whether it's going left or right. Y prime tells you whether it's going up or down.
Right.
And so you're meshing the two, right and up, right and down, left and down. Like the top one comes from x, the bottom one comes from y.
Okay.
There's a more simplistic example than this one, but you didn't get it. Maybe it was covered in class.
Right. Okay. Next one. I think these are fairly simple. Send this one first. If we have time, I'll send you another one. I've just never seen a problem like this in class.
Yeah, they assign web work, then they cover other stuff in class.
Right. It's insane.
Yeah. Okay, so they're telling you that a of t equals 4k, but what that really means is it's 0, 0, 4.
Right.
Okay, and so your v of t, the derivative of this is a constant, c1, c2, 4t. Oops, that's not written well. 4t plus c3. Okay, and that's where v of 0 equals j comes in. So v of 0 equals 0, 1, 0. That's what that means. And so we use that to find the initial values here. So v of t is, because there's nothing else there, that's 0. C2 is 1, and C3, when you put 0 in for t, it's 4 times 0 plus C3 equals 0. So C3 equals 0. So it's just 4t. You're just plugging that initial condition in.
Okay. Man, yeah, she hasn't showed us that.
It looks, this is not a complicated example. This would be a good one to study, because it's, you know, but they give you so little information. Like, how can I do this?
Yeah, I figured it wasn't too complicated. I was just like, I just hadn't seen anything like it. But in this one, I'm sure this one's simple too, but I just don't, like I said, I haven't seen I don't know how to solve a problem like this. It's like, it's a simple physics problem. Just don't, I don't know how to solve it with R of t.
Okay, so we
control
got,
equations.
see what we got here.
Oh, B is wrong, by the way.
Okay. Yeah, so stone hit the ground. All right. So the roof, when t equals 0, that's how you found the first position.
Yes.
Okay. And then it hits the ground when I, j, and k are 0. Which leads me to think that it's just simply setting 19.6 minus 4.9 t squared equal to 0. But is that how you got the 1.7? If you're not sure, it's okay. I just asking.
I remember in physics, usually there's a constant, and that constant is usually the height that you're at or the position in which you start at.
Yeah. So this ends up being 2. If you set that last one equal to 0, it ends up being 2.
Okay. Okay, that is right.
And
So
the
you're
reason
just
that's
okay.
because k is your well. So I and j, and this is bad, we really don't have a ton of time, but I and j come out. They're like the ground. I and j are the ground, and k is now your, like what you used to think of as y. K is your, so that's why you set k equal to 0.
Okay.
Now to do part C, I'll probably just have to talk you through this. You put t equals 2 into r of t. So you find r of t. So it's 4 I hat minus 10 j hat, and then 0 k hat. Well, we just did it.
Oh, you just plug. Okay.
Yes. Part D, you need r prime of t. So that's 2 comma minus 5 comma minus 9.8 t. And then you evaluate it at 2. So that gives you 2 minus 5 comma minus 19.6. But then because it wants the speed,
Right.
I think you need the magnitude of this.
Yeah.
So it's the square root of 2 squared plus minus 5 squared plus minus 19.6 squared.
Okay.
That would be your final answer on that. All right. Well, this will probably be the format for our lessons. If you continue to schedule, it'll probably be a lot of this kind of back and forth. I do have to look up stuff. There's just way too much here to.
Right. Yeah. I understand.
How
many Cal 3 students do you tutor?
Very few. So that was the other thing I want to say is, like, as you progress, I mean, I've helped up to graduate level math, but like, you're going to find that you're going to know as much as I do. And all I'm doing is sort of helping you navigate here. There's not as much teaching, but plus you'll also figure out how to do it on your own as you move through this.
Right.
And that's the goal, do it on your own, but
right. It's just a bunch of these problems I just hadn't seen, or I just hadn't seen before.
Yeah, and I'm happy to keep helping. It's just,
Yeah.
that very few. I mean, I got one other guy I'm helping right now with calculus 3, and it's totally different. They're doing contour plots and things you're not, I don't know if you will see. It's just a totally different course.
Yeah.
At this point.
Yeah. So will you send the notes to me?
Yes. Yep. I'm so that I'm way better. I got a little slow on that, but I get those out the same day, and the videos do take a day tomorrow to get out. But yeah, I'll send this to you in the next few minutes.
All right, cool. Thank you.
Have a great night. Bye now.
You too.